Yeah, so welcome to the AI Agent Moral Meetup. It's a meetup for people curious about AI, like you know, and we want to demystify AI and tech trends around it. Today, the goal is to see the test-driven agentic behavior, and we have the amazing opportunity to have you, Anthony. Don't hesitate to ask your question in the chat or along the presentation. We will try to answer it along the presentation or at the end. Do you want Anthony to answer along the presentation? In this case, I will unmute all mic if you prefer.
Well, what I would say is if 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 I've said something that doesn't make sense, and if it doesn't make sense, it would interfere with someone's ability to understand everything else. Maybe I haven't said something very well, and I could say it better. That's a good interruption. If it's to delve into the detail of something that I'm talking about, I'd say make a note of it because I probably will get to the detail of it in due course, but I'm probably trying to layer up the aspects of how all this stuff works. So clarifying questions, ask them straight away. Deep dive questions, save them for the end.
Okay, sure. So, just for new attendees, because we have a lot of people that join us at this time, we have a partial outage on the cloud status page, so we'll try to make the demonstration. But anyway, today we will have Anthony to the meeting test-driven agentic behavior. So thanks to be with us. The talk is recorded and I will share it on our YouTube channel at the end. The place is yours, Anthony.
Thank you very much. Right. Well, what was going to happen, and I'll share my screen, was I was going to talk through a few things, and then I was going to do a demo. That demo relies on Claude Code, and that relies on not having elevated errors across multiple models. If it's not working for, if Claude isn't working, that's something I'm dependent on in this scenario. So let's move my camera over here. I'm actually dependent on Claude working for this demo to go ahead. So I'm not going to be able to do the demo right now. If this situation changes, and I hope it does, then maybe we can actually get to it. But unfortunately, at the moment, it's not looking good. So what I thought I would do at the very minimum, because there is a video that's available on YouTube that does show this in action. I'm sure we can make sure that that's available to everybody at some point. In fact, I will get that now. Yeah, so what we'll do, I'll go through some of the elements of what I was going to talk about. I can show a couple of things, and then perhaps I can sort of show a bit of this video. Bear with me 1 second. I'm just going to click on it and try and mute it. Behaviors is my way of it. There we go. So what I'll do is I'll just bring that over. I'm not going to play it for you now, but I could probably use it as part of the demo, and then I can talk you through how it works. So ignore me being played there. I'll jump further in, and this will give me a chance to show it. It will, yes, it will. Okay, so let's try that. Let's try that. So we're going to try and get out of here and get over here and talk a little bit about an idea that I had a little while ago, how I got the idea and why, and specifically the things that I've learned on this particular journey of figuring out how can we take the principles of test-driven development and apply it to how we shape the behaviors of coding agents. I'm sure many of you have used coding agents before of some description. Perhaps Perhaps you're using Claude Code, perhaps you're using Copilot with some other mix of things, and will probably have experienced many of the frustrations that everyone else has, where you ask it to do something, you know you've got a skill in place to get it to do things in a particular way. It starts doing it, and then for some reason, it just goes completely off track. And you're like, well, why did it do that? So you go into your skill file, for example, and you make some changes, or you ask Claude itself, why did you do it that way? How could we do it this way? What needs to change in the guidance? And then you go in there. Now, I know some people I'm aware of actually just tell it to do things differently, and it says, oh, I'll remember that for later. But that only stores that in its local memory files. So that's not going to be useful to other people. Many more companies now are realizing that actually it's a good idea to make sure that your guidance files are shared across the organization. And therefore, if someone encounters an issue with the way it works, they'll make the change, see that it works, and then share it. But that's kind of a change and pray type of approach, which I remember doing back in the 90s, when I was writing software before we had test-driven development. I was making the changes, and then manual testers would have to do that work. Sometimes that was me. And then there would be weeks of testing to make sure it worked properly, and then you'd ship the code. Well, I'm noticing that as more people are investing more into the guidance files that create the behaviors that we want from agents in various settings, we're essentially doing what we used to do with code, but with agents. So I thought, well, how could we take the idea of test-driven development, get all the benefits of it, but with agent guidance, not just with code? So there's still people arriving. For those that have just arrived, I'm going to show a little bit on the screen. We have a bit of a problem with Claude at the moment, so the demo may or may not happen, but I've got a video that I can show, so we'll get to it. So my company is Riverglide. This is how I do my work. I provide services, consultancy, coaching services. Historically, it was all about helping teams achieve the elite benchmark in DORA's software delivery performance, so shipping multiple times a day, low defect rates, and very low error rates. And recently, I just created this brand underneath Riverglide specifically for what I'm doing today. And I'll tell you why Agentic in a moment. I'll do some level setting on terminology first. So I'm sure that everyone's familiar with this. I need some way of getting some feedback from people, like thumbs up, use the reaction feature, thumbs up if you've seen this picture before, you're familiar with it. Yeah, got a few. This is good. Okay, so this is the typical red-green refactor loop. Back in 2003, Kent Beck wrote a book called Test-Driven Development by Example. And that was the first, not long before that book came out, was the first time I'd really seen this picture. But the first time I'd sort of worked with it properly was in the year 2000, about a year after the original Extreme Programming book came out, which was in 99. And this was the first time I encountered this principle. And I thought it was completely back to front. And because of that, I loved it. I like things that are different, and I like trying new things. But it's a very widely misunderstood concept, because people have described this in various ways. And I've watched a lot of videos and I've spoken to a lot of people where some people have been told that TDD means writing all of your tests, then writing all the code to make them pass, and then you refactor. However, TDD was always write a single failing test, write a failing test. Then, that's the red part of the loop. Then you write just enough code, just enough, no more than is necessary to make it pass. Then you see it go green. And then you go through a refactoring loop of making improvements. And every time you make a refactoring, you run the test again, see them pass, refactor, run the test, see them pass, until eventually there's no more refactoring to do. And then you're ready to write the next failing test, and the loop continues. Now, most people think of this in the way that most of the TDD by example book was demonstrated, which was as essentially unit tests. However, something that was at the back of the book in the section Mastering TDD talked about an outer loop. It didn't use the term an outer loop, but it talked about TDD at the application level. But at the time, I think Kent said words to the effect of he hadn't yet seen it done particularly well, and it's not something that he had done a great deal of, but had done some. And I think at the time, Ward Cunningham, who he'd worked with on the original Chrysler project, from which XP was, I'd say, born or emerged, they also talked about the concept of a customer test. So the outer loop was always there. But a lot of us weren't aware of it, didn't fully appreciate it, didn't perhaps read the back of the book as in much detail as we should have. And some of us encountered various challenges along the way as we were trying to apply TDD. One of those people was someone called Dan Terhus North, or Dan North, as he was known at the time. And he created something called behavior-driven development. And behavior-driven development, another very widely misunderstood concept, today for a lot of people has been largely reduced to just given when then acceptance tests. However, when he created it, it was actually because what he had found is when he was learning about TDD, he found that there were a lot of lessons that he had to learn the hard way. He said it was less of a wax on, wax off process of gradual mastery, and instead a series of blind alleys. And he remembers thinking, oh, if only someone told me that. And one of those things was that outside in approach that I think was implicit or implied, if you like, by a lot of the practitioners before that. But you didn't really learn how valuable that outside in approach was until later. So this was around 2006. And then around 2009, a book came out that took things back to testing terminology, and that was the Growing Object-Oriented Software Guided by Test book. And that was the first time that they really showed in this particular way, this outside write a failing test, then go inside this loop, go round several times until eventually your acceptance test passes, and then you can write the next failing acceptance test. So why am I telling you this history lesson today? Partly because when I say TDD or BDD, for me, they largely mean the same thing. What you're looking at on the screen right now is, to me, TDD, BDD, their origins, BDD's origins are in TDD, although it has probably grown beyond that since then. But this is one of the simplest ways of looking at what TDD looks like for those of us who've been doing it now for 26 years in my case.
Just in addition, to understand well, the outer feedback loop, it's at what we call ATDD, right?
So I suppose there's a couple of ways of talking about it. So for me, because Kent does talk about unit tests and TDD for a lot of that part of the book, and then later he talks about ATDD. So some
Yeah.
people think of it as a different thing. I think of it as a subset of TDD, just like unit test TDD is a subset of TDD. It's just that obviously, this was 20 something years ago. I think when he started doing it for the first time, it was nearly 30 years ago. There are a lot of things that you might find a way of doing, and you don't necessarily find all of the best ways of explaining it at the time. There are a lot of things that are Mugridge and Cunningham in fit parallel to BDD. Yes, indeed. Thank you very much, Rob. Appreciate you. Yes, like Ward had created a tool called Fit, which was essentially a wiki-based acceptance testing tool.
And yeah,
Yeah.
I just say ATDD, it's test first and not TDD, or it's be part of TDD. Yeah.
The way I see it, and this is one of the reasons, one of the benefits of when Dan came up with behavior-driven development, he called it BDD. So he could just explain it however he wanted. And nobody could say, well, that's not TDD, because he wasn't saying it was. So, one of the stories he actually told me once a long time ago, for those who have joined, we're just discussing some basic principles right now. because there is a Claude outage. So the demo may not happen today, but we'll see. We might get there. Was that one of the gigs that he was on when he was working at ThoughtWorks, he wanted to try and talk with the developers there about TDD, but this was back in the early 2000s. And in those days, if you mentioned the word test to any developer, that was like, they'd look down on you and like, that's beneath me. I don't do testing. That's what the testers do. Go speak to them. So one of the challenges that he was having a conversation with developers about TDD, because they just didn't want to have the conversation because it had the word test in it. Obviously, things have changed since then. It's been quite a long time. But that was among the things that contributed to BDD, as he explained to me at the time. There are other things, and I do encourage people to read the Introducing BDD book. But to me, so this is about level setting terminology. If I say TDD or BDD, it might not mean how other people in the room hear it. It's just my way of explaining it. And I want you to understand that when I say TDD or BDD, see this picture, not that picture. Okay, so it's just to help me with the rest of the
Yeah, the inner and the outer loop.
Yeah. So when I say TDD, I mean the outer and the inner loop, and you start from the outer loop. That's what I mean by it today. Okay. I don't want to debate whether it's the right interpretation or not. I just want to explain this is what I mean by it, so you know what I mean. Now, one of the interesting parts about what happens on the inner loop, and this will become relevant, but one of the interesting things that happens on the inner loop, when people write a failing test, one of the things that sometimes happens is they write a little bit too much code to make it pass. And this is from an article that was somewhat inspired by a discussion that Nicholas was involved with a little while ago with somebody, partly about mutation testing and myself. So if you imagine this scenario, hopefully you can see I'll make it a bit bigger just in case people have got a smaller screen. So if you imagine you're writing a test for a FizzBuzz evaluator of some description. So the right way of doing it would be, you say, right, assert that the thing I got back was fizz for 3. The implementation that you then do to make that pass should just be return 3. Then if you want it to work on the basis of if it's divisible by 3, then you add your next test where it has to be 6 and it gives you fizz. And then that drives you to the simplest thing that could possibly work, which would be for it to be a number divisible by 3. Now, what tends to happen, I've seen this a lot, and this is how you get lots of mutants in your code, is when you write, what tends to happen, people tend to write this step and then jump all the way past all of that stuff and go straight to here and just implement the thing. So what do you end up with? What do you not have if you just go from that one example and go straight to this? What happens? Anyone?
Can open your mic.
Yeah, you just have to unmute yourself. Anyone? What happens if you write this step, this assertion, and then jump straight to implementing that? Does anyone know? What do you get? Or what do you not get? The clue is that you won't have this test. So if someone, for whatever reason, has a reason to change this, and they change it in a way that, if that test existed, would have failed and would have made them realize, oh, I shouldn't be changing this in that way, that's what would happen. But if that test isn't there, then they can change this. They could actually remove the divisible by 3 and just return 3 again, and no test would break. And as far as they're concerned, everything's fine. Now, this is a trivial example, intentionally so, to get the point across. But when you're dealing with code that's a bit more complicated than this, those additional tests that you would have had if you hadn't skipped over those steps is the protection that your business rules or the behaviors in your products continue to work the way they're supposed to. And this is where you end up with mutants in your code, where mutation testing tools can literally just remove that and remove that. And what you end up with is just 3 and no test fail. And then it says, right, you've got mutants in your code. and the tests did not find that mutation. So you've got low mutation coverage and low test coverage. So that's the issue. And the reason I'm explaining that is because that's actually quite a common thing I've seen. I've coached a lot of people in TDD over the years, and that's quite a common step. And you always say, what made you implement that particular algorithm there? And they're like, oh, well, that's how you do FizzBuzz. Like, yeah, but did the test make you do that? And then it's like, let's just take a step back, go back to the test, revert that. What does the test require? And then eventually I was like, well, 3, but oh, that's too naive. It'll never work. And you're like, yeah, but let's try it and let's see what happens. And then they do it, and then they write the next test, and then they see, right, the next test forces me to implement the algorithm. Great. Now, this is very common. Oh, by the way, there's some new people joined. We've got a Claude outage at the moment, which is unfortunately, I did have that up on the screen a moment ago. There it is. And it still seems to be the problem. So the demo, I'm stalling a little bit to talk about some principles, but I will show some stuff about how it all works in a minute. So what I noticed when I started working with various like Codex and Claude in particular, is that they did exactly that. They would write that test and then jump straight over it and implement the entire formula. And I was like, well, that's not TDD. That's going to leave me with gaps in my test coverage. I don't want that. So I'd have to get it to stop doing what it was doing. I'm like, undo all that stuff you just did. Let's try again. And then I would have to change the skill. I was trying to create a TDD skill of my own because I wasn't satisfied with any of the others I got, because even they often would not prevent this. So I was like, well, I want to try and create my own TDD skill for this. And I would write the change that I wanted to make to the skill, sometimes in collaboration with Claude. And then it would sort of work and then not work and then work and then not work. So then I'd say, like, yeah, but don't do this and then don't do that and don't do the other. And eventually I got it down to the point where, now it's actually triangulating consistently. The thing is, that just felt like old school manual testing to me. And I was like, why am I doing this? This doesn't make sense. There must be a way of being able to create a scenario, give that to an agent, have it perform the scenario and evaluate whether it did it the way it was supposed to at the end in an automated way, so that once I got it working and I went and made that change, I know for now, until the model changes or some other factor changes, it's going to work. So that led me on this journey of starting an experiment, which I think the experiment is largely over, and now I'm going to turn it into an open source product. But because Claude is down, I will switch to this and I will show. Booking.com has all kinds not of an advert. Because I will show. It was that video there. Let's just close that. I will show this clip of the video. I'll just talk you through it. So actually, before I do that, let me show you the anatomy of one of these scenarios. Let's clear that. Yeah, I was having these problems before you folks arrived, and that's when I was like, what's going on? And the first thing I should have checked is Claude having problems? And it was Nicholas that told me, oh yeah, Claude's got a partial outage. That's probably why you're having problems at the moment. So here's what one of these scenarios look like. And this is why I mentioned BDD. So this is the outside element of the loop, and the inside loop comes up in a moment. The outside part of the TDD loop, but for an agent. So what I have is a scenario that describes that given I've got a clean fixture, so I've got some example code, which I'll show you in a moment. And it's got a placeholder test. I'll show you that as well. When the agent performs TDD, red, green refactor, then the code was arrived at one test at a time. And then I reset the fixture. So what does that mean? So in here, I've got a prompt. The way that it works is it starts up a background sub agent, and that's important. It's not forked. If it's forked, it carries the context from the parent agent. If it's a general purpose background agent, it doesn't carry that context. So it only has the context that you give it. So I basically lock down the scope here, and I've got tests that actually prove that it only checks the things it's supposed to. And I give it a simple task. And this task in this case is just use test-driven development to implement these two things. Now, this happens to be using some Kotlin. And that's only because the thing that I started working on was actually Kotlin, although that's shifted now. But I'll solve that when I actually implement the full open source version. So what I have is an example implementation in Kotlin, which is just an empty placeholder test. So that placeholder test is just really there just to give it a place to start, because I'm not really testing whether it knows how to create a test file or not. I want to see what kind of tests it creates and how it actually creates them. So that example test exists. Back at the, let's close all of that stuff, come back to that, come back to that. Back here at the test, the next thing it does, so that sends off an agent to go do that small exercise like a mini coding kata, and then a separate agent is started up to evaluate how well it did that particular job. Let's make that a bit bigger. And it has a few things available to it. One of them is it's got a reference test, so an implementation example. It should look something like this in the end. And this exercise is just a miles to kilometer converter. And then it's also got a reference implementation for what the code should look like by the time it's finished. And that's where you've got this miles times 1.60934. And what I was seeing when I got it to do this exercise at first was that it was writing the first test and then just goes straight to miles times 1.60934, just like in the FizzBuzz example. So I had to put in some guidance to stop it from doing that. And that was kind of what started this whole process. So the scorecard exists for a few different reasons. It's not like we're not evaluating deterministic results. So every time the agent does something, it could do it in a slightly different way. So this is technically required because it's 100%, but I left that there just as an example to illustrate that what you can do is you can actually score certain things up to a certain percentage. And I want to say a very special thank you actually to my brother Raymond, who's also on this call, Raymond Rodriguez, because it was him who kind of gave me the idea of using something like this type of mechanism about grading things in percentages. And then I was like, oh, it's a scorecard. And essentially what it does is it makes sure that the tests pass, that the production function exists in the place it's supposed to, in main. While it's running, it generates a transcript by some code behind the scenes. Once the test gets kicked off, reaches into the sub-agent's log files and pulls out everything that it's doing and then renders it into a markdown file for easy review. It's actually in JSON by default, but this code just kind of like pulls it straight out JSON programmatically and puts it into a neat file, which I'll show you in a moment. So what it's saying is that it looks in the background transcripts and makes sure that there's 3 to 5 increments identifiable from looking at tool usages by the agent. What that means is that if it went from writing the test and straight to the formula, that would only be two increments. If it writes the writes the test and has one failing answer, that's 1 increment. And then if it jumps straight to the formula, that's 2 increments. That would also fail. So it has to get a failing result, then get a pass on the first test, and then get a fail on the second test to get to its next pass. And that should be proving that it's actually getting there in the right way. So it's not just about evaluating the result, the output, it's also about evaluating how did it get there. And then the second example caused a test failure that required a code change to pass. There's another thing it's checking, and there's a few more things to make sure that it's not just evaluating the code it produced, but also the technique it used in getting there.
And do you keep the background transcript after, or just to understand the process? Yeah.
Yeah, I can show you an example of one. It's
Yeah.
git ignored. It's git ignored, but I do keep them. And then what I do sometimes is I'll copy them. Where is it? There it is. I will copy them into like if I write up a document about something that I changed, I'll copy those transcripts in with it, so you got the backstory behind it. And then
Okay,
we'll try
sure.
and find
You have
we'll try
all
and find
the whole process in the log. We have a question from Robert. What about evaluating the veracity of the test? I think it's maybe mutation testing.
Sorry, say that again.
What about evaluating the veracity of the test?
Well, the veracity of the test in this particular example, I don't think is applicable, because what we're trying to do is these tiny atomic incremental tests, unless I misunderstood what you mean.
If you want
Rob,
to
Rob, do you want
complete.
to speak up?
Robert. Yeah, you can open your mic. Yeah.
No, I was you're looking at the veracity of the result, but if the test is a weak test and the result is positive, it's not advancing your development. That's why I just wanted to ask about that.
Um,
In your example, you're right. So it's in general, someone can do TDD with a weak test and
yes, yes,
not
yes.
get anywhere, but follow the TDD method. Your picture is going to be perfect, but you're not going to get anywhere. That's what I was driving at, Anthony. Sorry.
That's a very good point. And actually, I've seen that a lot. Like with, there was one company that I was sort of brought in, one of my clients that I was brought in to help them with a few things. And one of the things was they were concerned about their test coverage. And I said, well, how have you addressed it so far? And they said, well, we set targets for all the teams for test coverage. I went, let's have a look. So we started having dig around, and lo and behold, the test coverage was high. All the lines of the code were being exercised, but none of the assertions meant anything. None of the assertions would break if you broke the code. And so that's a really good example. Like if it just writes a test that isn't really proving anything, it's just exercising that path, it's not asserting anything on that path, that would be a really good example of it being bad. I haven't seen that problem yet. I haven't seen it, but if I did, I would want to write a test to reproduce
Yeah.
it in this way.
I,
See if
I'm a
they
bit
have.
biased, Anthony. When I'm looking at this, I'm thinking of how do I make work for my McGill students, and they're going to trick me into getting an A by doing crappy testing.
Ah,
So,
well, make sure that they have to supply mutation coverage as part of the
yeah,
report, because
no, I
you
think
know,
that's beautiful. Thank you. Yeah, it's a
yeah,
good idea.
yeah. But for anyone else, like mutation coverage, I think mutation testing is an important thing to be doing with your agents, because it will then catch all of the gaps that it's leaving in the tests. So even if the test veracity is low, then what you'll have is very high mutation coverage, because you can mutate the code and no tests are failing. So that's a really good sort of segue there. Right. So this is an example of one of the transcripts, where it this is from the beginning of the JSON log file being created. I actually get the agent just to emit what model it's on. And then after that, everything in here is directly pulled straight out of its log file. That also, I've got another test that makes sure that it's not reading beyond the scope that it's been given, because I don't want it to have context that I don't want it to have. Otherwise, it pollutes the integrity of the test. But that's another conversation. So, so off it goes. It's run some tests. Increment 1, failing test for 1 mile to 1.6. It creates the test, it thinks about it, and then eventually it creates the test, right? So here's the first test, it's created there. Then it runs the test again, and it gets a failure. So now it decides, this is one that's worked correctly. Now it decides it's actually going to just put in a dummy value so that it's getting a meaningful failure, because previously it actually got a compilation error, I think.
Just in addition to the logs, the agent did micro commit for that or not?
For this, because again, this has been largely experimental for me. I've switched off commits for now, because I just
Okay.
didn't want that. Then I'd have other infrastructure to make. Then I'd have to get every agent to create a branch, do its thing, commit. Then I'd have to tear down the branch. When I do implement the real deal, it will do that. But in this case, I've had that completely. I actually had it, and then I switched it off. I was like, no, this is This is too much.
Yeah, sure. Because it was one of my question in another debate, if we need to squash or not the micro commit,
I'm not
because
starting that
we
conversation.
lose the micro step of the what. Okay.
I'm in favor of keeping all history. That's me. I think keep all history, because there's always, there's when squashing the commit's great if everything goes well. If
Yeah,
something goes wrong and you squash the commit, much harder to unravel what happened. So, but
sure.
that's a different conversation for another day.
To understand the what happened, you need to have the Git history, right?
But I commit, generally I commit on every green. Like every time I get a green, that's a commit, that's a commit. And on many of the projects I work on, they tend to be more trunk based. So we'll branch by abstraction rather than branching using Git. So I will generally commit and push on every green. So in this example, it's changed this is showing the before and after. It's changed the 0 to the 1.6 hard-coded response. So this is working the way you'd want. Now it's gone over those 3 increments and it's got to a good place. And that means, I think there should be 4 increments, 4 to 5 increments for this. I think that scorecard is wrong. And then finally, it makes it adds another test and then continues on to the 5th, which then makes it pass. So yeah, I think the scorecard is wrong. I was actually hacking around on this a little while ago, trying to figure out what was going wrong with it. So I'm going to say must be over 4 TDD increments. There we go. Problem solved. So that's the anatomy of the tests. What you have is you have your scenario. Within that scenario, I'll show you the folder structure as well. Pull this out. That scenario sits under a folder in a markdown file. Each of those links goes to a tasks folder. And then if there's a reference implementation for that example, then that also sits in the same place. So you can still see that there. So the thing is, everything's all together because at some point that test might become irrelevant. So you just delete the whole folder when it's gone. Or you might want to refactor something. You just refactor it all in that folder. So that's how that's structured. And do you know what? I'm just going to take a chance. Let me just see what's happening with Claude. No, that one.
I see. Operational, no?
Monitoring the results. Right. Do you know what? I'm just going to run it. So this experimental thing is called Test-Driven Agentic Behaviours, or TDAB. And there's a skill that runs the scenarios. I'm starting this fresh because I thought, because of the problems, I didn't really want to be left with a stale environment. I'm going to run this. If it doesn't work, if Claude has problems or it starts taking too long, then I'll just show you the video clip. But while it's running, I will then also show you how it works as well, because that's quite an important thing. Right, so it needs to have accept edit on, because if I don't, the subagents get permissions problems because they can't work freely. And then I'm just going to give it a very specific path for the purpose of the demo. And another interesting point is the first one, the first suite on the list here is actually a self-test. So it's basically testing itself using exactly these same scenarios as well, which I'll show shortly. So what's going on here? Well, I'll get a I'll show you what's happening. So when I started it off, it did a pre-flight. Let me just make that a bit bigger because, again, people might struggle with the size. There we go. Move that over here. Over here. So what's happening here is it does a pre-flight check. There's some code that sits behind this. It runs some unit tests, but it only does that once at the start of a session just to make sure everything's working. If it's a suite, it goes down one path, or if it's a single test, it goes down another path. If it already has been told what test to run, yeah. So let's just go. We went down here, it showed me the suites, asks me to pick, and then it collects this test or suite identifier. Then it finds that, and if it's a suite, it runs the suite route, and if it's a single test, it runs a single test route. This is still going. Look, it's running. And what you can see here is that it's actually spawned a number of background agents. So 4 background agents, one for each of these steps. And what happens, what is going on? What happens, what tends to happen is the each of these steps is started in parallel, but they only perform their work when the previous step has completed. Yep. And again, I can show that in a bit more detail in a second. So during this single test run, what it does at the beginning is it calls some code behind the scenes. And again, anything I can do in code, I do it in code because it's deterministic. And I try to leave only something that requires reasoning to be carried out by any of the agents. So it runs an init scenario process, which creates something called the stage director. You'll see a stage theme and theater theme coming through here. Starts the stage director, and the stage director basically gives it. Show me that. I need to make that bigger, don't I? It was larger earlier. What the stage director does is it gives it back some JSON, which is basically, here's the configuration for this test. So the foreground agent in this case is pretty dumb in the sense that it just takes that and just calls its agent tool with each of the parameters that it's been provided. It doesn't augment it. And that was done for a reason, because I found that if you didn't do it this way, the foreground agent would be like, oh, let me help them. Let me tell them how to pass the test. And it would start passing in extra information. It's like, nope, that's not how you do it. You just get this information back. You call your agent tool in parallel for each of those agents, and they run in the background. And you can see they're still going here. It is a bit slow, and it's that time of day for us. That was, once it gets that back, the queue rehearsal is what happens when it spins up these parallel agents here. And then it sits there waiting until each of the agents has finished doing its work. There's another thing for the self-test, which we can ignore. And then obviously if it passes, it reports using the pass report, and queues a time recorder. So it captures some data, how many tokens we used, how much time it took, and then also queues the report fail. Now these are just normal like MD files that it refers to, that it uses to generate the report. And this particular test passed, so it didn't really do very much there. I was actually expecting it to fail, and the reason for that is I've actually removed a bunch of guidance that historically I had to add in order to get it to triangulate. But for some reason, now that I've removed it for the purpose of this demo today, it's just working. And I was like, why is that? So I went back and I realized that when I did the demo before, it was under Opus 4.6. And this is now under 4.7. So I think 4.7 might not need that guidance anymore, which has resulted in me having a new use case for using this, where you can start to identify the guidance. You can run this test, remove guidance. And in fact, you could you can pretty much put it in its own Ralph loop on this. Get it to run the test, get it to identify guidance that it thinks is making it pass, remove it, run it again. If it still passes, remove more guidance, and keep going until eventually you're left with only the guidance you need after a model update. The first application I had of it is when Opus went from 4.6 to 4.7, what happened to me was I hadn't pinned the model. I pin it now in my settings.json, so it's just, at the moment it's pinned at 4.7, but it wasn't pinned. So I'd run these tests, I went to make a cup of tea, and I came back and I went to run another test, and it failed. It was like, that passed literally 10 minutes ago. And I was pulling my hair out for an hour. So I took another break. I went and looked on LinkedIn, and one of my colleagues was like, oh, Opus 4.7 has just been released, and here's all the cool stuff about it. And I was like, oh, is that it? So I went back and I went into the settings and I pinned it back to 4.6, ran the test again, passed. Everything passed. So then that allowed me to, having confirmed that everything passed on the 4.6, then pin it up to 4.7, one test at a time, go through and see why that one test was failing, change the guidance to make it pass, go back, run the test again until eventually it passed. And then what I do is if a test passes, I have it run. What I found now is it's enough if it runs 5 times over and doesn't fail, then you've covered off all the potential variations. If you get it on the first pass, it looks good and you just trust it, that's a mistake. Because you try it again and it might do things slightly differently this time and cause the test to fail. So then that identifies a gap in your guidance where you can go in, change your skill file again, run your test again, see if that plugs the gap. Oh, it's passed again. Great. Run it another 5 times. And then eventually, it'll go from, failing 3 out of 5 times, then down to 2 out of 5 times. You change the guidance again. Now 1 out of 5 times, you change the guidance again, and it will go down to passing every single time. And at that point, what I found is it doesn't matter whether I run 5 or 10 times. After that, it's just remains consistent unless something else changes.
Could you show us where we have precise this?
Could I show you?
To execute 5 times the test? Or...
Yeah, I'll tell you what I'll do. I'll show you one of the self-tests because it's a little bit quicker.
Yeah.
It is... Just I'm lazy.
Yeah,
I should go and find it myself.
Test.
So it should load the test, call the stage director. In fact, there's a diagram I can show you for this. That's the one. So what's happening? Oh, wait, hang on a second. This is definitely something to do with Claude having outages because it's not supposed to do that.
Yeah, bad day, Claude.
Definitely the wrong day. Yeah. So what would have happened is that if Claude was being normal, which at this time of day in the UK is the worst because it's kind of like still in work hours here, but also peak work hours in America. So it's in North America. So you just got this overlap. So I'm actually going to kill all of that. Kill that. What should have happened is it would have just run those repeatedly rather than not. So what happens in this scenario? The user says run this particular test. The session agent calls just a bit of Python. It's a console command essentially in Python, passes it the name of the test file, and that command parses the test file, extracts the steps, builds a simple JSON model, identifies prompts that are based in a template that tell each agent how to work, because the given, when, then, and finally steps have to work slightly differently. So it pulls them out of a template file and then constructs a prompt for each of the steps and then hands the whole JSON back to the foreground agent. Then what that does is it starts up a sub-agent for each of the steps. Once they're running, it calls another command which starts up the transcribers, which then go and start monitoring the log files, and then that starts the transcribers. They provide back information about the path name that they're transcribing to, so if you need access to that at some point. And it also provides details of the location, the agent IDs, and the location of the JSON files, and ultimately spawns each of the transcribers and watches them. And then for each one of those sub-agents, what they do is, this is the sub-agent here. What they do is they call the stage director and say, we're ready. And then the stage director is waiting for the previous step to say it's done. As soon as the previous step says it's done, it says go to the next one. The next one starts doing its work. Once it's done its work, it then says, I'm done. And that results in the stage director giving go to the next step, and so on until they're all completed. The reason for doing that was, at first I had them more sequential, and it just made everything take too long. And there's another test that actually runs that that actually tests to make sure that a when step, if it's got reading it can do or research it can do prior, that's relevant to the task, prior to getting its go, it just does the research, as long as it doesn't execute anything that's environmentally affecting, doesn't run any tests, doesn't change any files, all of that stuff. And that just means that the given step can run, but the when step is overlapping in its preparation and only goes when it goes, it starts doing the real work, not the research that it's trying to do. And once they're all done, then the test is done, and then it generates some outputs. That's essentially how it's working. So most of the orchestration is actually done entirely by code. All this foreground agent is there for is to allow you to use this under your monthly subscription and not have to deal with extra API costs. And also, if a test fails, then you can have a conversation with the foreground agent, and it can then go off and investigate the transcripts and figure out what went wrong in that scenario, what could it have done, what should it have done, what guidance did it follow, and so on.
Yeah, the transcribe step is so important to understand the issue.
Oh, yeah, and that has been actually a lifesaver, because there was about a week ago, for some reason they changed the way that you start background agents. The default was that if you started an agent, it would start as a general purpose background agent, would have no context from the parent, and you could just give it its work and it could do it. And then for some reason, they all started as forked agents. And I didn't actually notice. It's actually in another demo that I did, that I recorded and I put online. And I saw, hang on, why are they forked? Let me go and look into that. And their documentation hadn't changed. It was still saying background agent should be default. So I then had to go in and change the init scenario so that it would make sure that it provided the background agent parameter, forcing it to start everything up, not as a forked agent.
So just to understand, when you start, you write the BDD, the business case, or can you integrate some like zombie acronym, or something like that inside, or
Can I
integrate the zombie acronym?
Not something I've considered.
Okay.
Yet, but I'll add it to my list.
Yeah, sure. I think you can also add in the red green mutate refactor step. We can integrate a mutate state in order to just execute the mutation testing on changes files. Yeah.
Yeah. So this is very frustrating, as a part
For
of me
cloud,
wants to,
yeah.
part of me wanted to cancel. Yeah, for anyone who's joined late. Oh, now it's operational.
Just before, we have a question from Red. Am I correct in understanding your meta structure consists of play agent parent, test agent background, and scorecard agent background?
Correct, with the exception of a couple of the self-test scenarios, because I haven't got to the. You can run a series of background agents in one set, and then where I got to with this was to evaluate their work. The foreground agent runs a step in order to evaluate how well they did. I want to push that down into a background agent, so you can have a batch of background agents and then a batch of then and finally agents that will run afterwards. But I decided not to spend any time on that because I kind of know that's what I want to do, and what I want to do now is actually take what was essentially experimental and turn it into a proper open source project that other people can start experimenting with too. This was just very much a me hacking around. I didn't know what the questions were. This was me trying to find the questions. Then I found the questions and I've got some of the answers, and now I've got enough of the questions and the answers to turn that into something more solid.
Yeah, is it the last attempt? Yeah.
Yeah, we'll see. It says it's green now. It was, for those who may have joined later, you see that orange bar there.
Perfect.
That orange bar there. But yeah, what I was also going to show, which might be of interest, is the skill that sits behind this. I mean, just hypothetically, you can see all of this stuff happening here. I showed you how it was dealing with all the background agents. You'd imagine that's quite a comprehensive skill. And this is the thing that I've been spending most of the last week on, is the skill. That's it. And the reason that that's it is because the thing that that's following is actually the diagrams that I showed you earlier. So these diagrams are using plant UML. This was actually inspired again by my brother. Shout out Raymond Rodriguez on the call. About a year ago, he found that he was getting more consistent results. There we go, that's all done. And then if I say run subagent steps 5 times over, I'll see what it does. See if it does it properly this time. He had found that he created essentially like a pseudocode, almost a whole programming language, in fact, arguably, for ChatGPT to create custom GPTs. And he said he was getting more consistent results if you tell it what to do in a way that looks like code rather than prose, rather than written words. And that sort of sat with me for a while, and we were talking about it and talking about it and talking about it. And then, but I couldn't see how to take that and make it accessible to other people, because if you looked at what he'd done, I mean, it's a whole new programming language you'd have to learn. And at the moment, it's all in his head and nowhere else. So I was like, well, we couldn't use that. And recently, when I was drawing some diagrams to help explain how this stuff works, I was like, hang on a second. That is its own DSL. What if I could get Claude to read that and follow that? Obviously, it's not looking at the diagram. That's just a render. It's looking at what's in here. So what you'll see is, as it's working its way through, doing each of these steps that are rendered in this diagram, it's actually interpreting the plant UML and carrying out the steps based on what's in the plant UML. There's an interpreter file that's about 60 lines long that makes that possible. There's a small DSL on top of that, where if you queue something, it's got to have a link, and that link takes you to either another plant UML file or to a prose file. Inform means tell the user something. Find means go find it. Ask means ask a question and wait for the answer. Then take the input, and each of these little drop down things here is basically assigning it a label that the LLM is able to keep track of in a simplistic way and pass that information through down to these other steps, which, my first instinct was, it's an LLM, it can't do that. But you're asking it to do the same thing when you just type written words, use this information from here and pass it there. Exactly. So Red has said a flowchart provides determinism, whereas prose utilizes chag text, which essentially means that it can be open to interpretation. I actually ran some tests because I'd written this in prose originally. I recently tried this as an experiment, and then I compared the number of defensive statements I had to make to say, I say what I want it to do, but then there's all these defensive statements, and don't do that, and don't do this, and don't do the other. The density of that was 14 statements per 1,000 words in prose, and 4 statements per 1,000 words in here. So it's a very, very big difference. And I felt it because I was focusing entirely on what I wanted it to do most of the time, as opposed to before, where I was focusing more on what I didn't want it to do, if that makes sense.
Yeah.
Right, so there you go. It's actually working now.
Yeah.
It's green. It's all passing. Well, maybe I can come back and actually show another more thorough demo, and maybe I can explain a little bit more about how this works. But if anyone is interested in how that works, I can point you at, I literally just put this up this morning. So it's called Stagentic Prompt Book. Stagentic is stage and agentic put together, because the idea of the tests is that they are essentially your auditioning agents who are doing automated rehearsals and then evaluating their performance. And if their performance falls short, that's on you to improve the directions that you give them. So you give them better direction, then they rehearse again, and then you evaluate the performance. And that's the concept behind it. And in theatre, a prompt book is the stage manager's master copy of a play. I'm not really into theatre that much. You wouldn't believe it, but I just like metaphors that help you understand things. So prompt book is actually a stage manager's master copy of a play. It's got everything, the cues, the light, the sound, scene changes, all of that. And that just felt like an appropriate name for this, plus the play on words of prompt and whatever.
Yeah.
So you can go and check that out. It's github.com/stagentic/stagentic prompt book. And at the bottom of that page, you'll find some links to me as well. Shout out to my brother again. And if anyone wants to support this work, they can subscribe on Substack, LinkedIn, and YouTube as well.
Sure.
I'll leave it there. If there's more time for questions, I'll take them. I just want to say, on behalf of Anthropic, I'm really sorry they ruined my demo by having an outage.
Yeah, thank you so much, Anthony. I will share anyway the link of the GitHub page on the comment of the video. I have one question about the diagram because it's truly interesting that the agent follows the diagram. Just if you make a change in the diagram, do you see the change, or in the
Yeah.
commit you see only the whole file change?
You'll see the pummel file change, yes.
Okay.
I think there are ways of rendering diffs on Plant UML. I've seen that before. I've
Yeah.
not used it, but I can't see any reason why you couldn't do something like a diff where, it put everything that's been removed in red and everything that's new in green or something like that. I've not seen it done. I mean, I'm very comfortable with Plant UML. I've used it a lot over the years, and I can read that and know pretty much what it's doing. So
Yeah,
I'm comfortable seeing a diff. And also I tend to work in tiny increments as well. So if I'm going to change something, I'll add one box, maybe 2, and that's it. So the diff will be this.
Yeah, it's very
very,
small.
very small.
But my point is, do we see the change in the history and its version? But it's difficult to see the change. Okay, you need another tool to read the diff of the UML. Okay.
If you want to read it visually, yes, you can't see it. But Plant UML is just a pseudocode that you render into a diagram. I think once you work with it for a little while, it's like the Matrix. You stop seeing the code. You start seeing input, output, question. you start to just read it and, well, I know what's changed there. And I think also, I think that in a way, the diagram, you can always see the before and after of the diagram, because you can access, both commits, you can see them.
Yeah.
So I don't think there's any particular reason. Mermaid is another option I've considered. Yeah. So thanks, Etienne. Yeah, similar to Mermaid. I think Mermaid's actually got a diff tool, if I'm not mistaken. But not something I've looked at.
Yeah,
Literally, I actually got this working 2 days ago, and I spent most of yesterday running these tests back to back, collecting token usage and measuring performance against the pros version and the new version, which again is another use case for this. If you've got a skill and you want to refactor your skill, well, then you'll have tests where you can move your skill from pros to plant UML or whatever else comes out along the way. And as you move it over there, you can run it back to back, see the old one still working, try the new one, see that that doesn't work, tweak it, change it, keep repeating that process until eventually you can run the test against the old skill and the new skill. And once that works, then you can delete and deprecate the old skill.
Okay,
So that's
thanks.
another scenario.
I will think about the diagram for my own process. We have a question from Red again. Yes, a flowchart provides determinism, where a prose description it utilizes the check text generator, which is probabilistic based. Just to
Yeah. This increases determinism, but it's still an LLM, so it's still open to interpretation. What again, as I said, and this is one of the things that again my brother found as well, is that at first he found that it improved the determinism of the results, but didn't completely solve it, and he's had to do other things on top of that in order to improve how deterministic it is. What I found is that I'm spending more time when I was working my way through implementing this and getting it to work. I was spending much more time just telling it what things I wanted it to do, as opposed to the things that I don't want it to do. There was one, was it in here? There was one command. Again, it's like a needle in a haystack. That's a sweet. There's a command that says, and don't do this and don't do that. It was in the single test. There we go.
Okay.
Any failure equals fail. Do not repair or retry. That's the only statement in the plant UML that I had to add to tell it to not do something I didn't want it to do.
We have another question.
Yeah, so Anthropic skill creation also runs multiple evals. So I've kind of looked at that, and it's characterizing something that you've kind of got it to do. Whereas what this is doing is it's allowing you to think, what do I want it to do? Let me provide an example of it. And when I say provide, I don't sit here and write those scenarios. I didn't write the code, all the scenarios for that test. Once I'd created the first one, Claude did that, and then I just give feedback on it, or I'll make a few little tweaks. And I didn't like that bit here. It's doing that. But what you're doing is it's particularly useful if you're not 100% sure exactly how everything's going to work, but you know that one thing isn't right. And the idea is you build up your scenarios for your skill that you can run and evaluate against anything. The other thing it does is I can configure what model I want the when step to use. So the when step at the moment is set to Opus. But if I wanted to, I could rerun these tests on Sonnet and see if does my skill also work on these different things. There was another question which I missed.
From Etienne. Any tips on how to test the effect of multiple skills being loaded?
Yeah, so there's no reason why I couldn't go over here. Go to the example that I had earlier of the red green increments. So if I go in here and we go here, this is just a prompt file. There's no reason why you wouldn't be able to then tell it to load different skills. Now, what I've been doing is, where possible, pushing as much as I can down into code. So there's no reason why you couldn't get it to make a bash call. I've been using Python console gateways essentially, but to call that and for it to give you back the next model that it should run against, and then just have it cycle over and test a different model every time, and test a different configuration of different skills being loaded in the background, because that will change the context. Yeah, there's no reason why you couldn't do that with a little bit of work. It's another potential valuable use case. Again, because like if you can inject different elements of context and then see how does that affect the behavior of the agent, there's huge value in that.
Okay. Do you have some other questions from attendees? You can open your mic. Sure. If not, thank you so much, Anthony, and I will share the video on our YouTube channel. Feel free to send me useful links and also the GitHub link. Thanks for our attendees, and see you at the next meetup. Thank you so much.
Thank you, and thank you for everyone who chose to come along. And I'm sorry that Claude went down, and I'm sorry that we couldn't show you the whole process, but you saw that when Claude is actually working, it does actually do what it's supposed to do.
Yes, anyway, we can reproduce with GitHub. So thank you so much, and see you soon. Bye.
Bye, everyone.